Well, yeah, I think we can start. Just a quick introduction of myself. My name is Irina, and I'm the person behind these emails that you got with the invitation to participate in the meetups. We have these meetups every 2 weeks, sometimes even every week. In this case, now we have a VR architecture month. It means that the whole month is dedicated to VR, AR architecture topics. And yes, I'm very happy to see you all. I'll give a word to Stefan, so he'll introduce the speakers and we can slowly start.
Thank you, Irina. It's great to organize this together. You from the XR community representing Virtual Playground. I'm representing the VR lab at the Faculty of Architecture. And an important part of this series is for me that we have the Virtual Reality Design Methods Lab, the field lab from ClickNL. And the past 2 years we did projects, but we also started a couple of new projects. And today it's about the new projects. So it is Leon Hietbrink from SVP who will be presenting the International School in Utrecht project, where VR is used as a part of the design strategy in the Signet system. And the second project is called BioMirror. It's very intriguing as well. It's about using sensors and architectural objects and see how people react on that. So I'm looking forward to these presentations. Leon, I think you're the first one to present.
Yeah, thank you for the introduction and thanks for the invitation here to speak today. I will share my screen.
And meanwhile, I encourage everyone to leave your questions in the chat, so it will be more comfortable for all of us to list these questions afterwards.
Yes, so everybody can see my screen now.
Yep.
So in this presentation, I will tell you something about the VR research we're doing for the International School in Utrecht. I will tell you a little bit about the office I'm working for, that's SVP, how we're working with VR right now and how we want to do it in the future. And then I will go to the project itself. So my name is Leon Hietbrink. I'm an urban designer at SVP. And I plan to do this presentation together with Wilco Huppelschoten. He's one of the architects of the International School and also working in the VR project. But unfortunately, he's unavailable at the last minute. So I will do it on my own. So if you have questions about the building itself, hopefully I can answer them. And otherwise, I will ask them later to Wilco and I will find a way with Irina to give the answers to you. So SVP is located in the middle of the Netherlands. We're working from Amersfoort. Our main, most of our projects are in the Netherlands and we have some in Russia, but mainly we work in the Netherlands. So it's really well located in the middle. We're an all-round design office, mainly focusing on urbanism and architecture. And we're with 40 people with all kinds of specializations, but mainly urbanism and architecture. But for the bigger projects and the more complex projects, we also need a lot of specialized people who are not working in our office. So that's why we work together with landscape architects, mobility experts, sound experts, depends on the project. So for example, for this international school project, we're working with the architects of Cross because the SVP architects are specialized in elementary schools for kids from 6 to 12 years old. But the people from Cross are more specialized in the bigger buildings, in more public buildings, for example, Rotterdam Central Station. So for this project, we decided to work together. And I think that's one of the main reasons we got this project, because the international school is for kids from 4 till 18 years old. So it's really a big school. And with both our experiences, I think we're really fit to do this job. And now in this phase, we're also working together with the TU Delft as VR experts. They're really adding something to the team. And for them, it's also nice to see, I think, how architects in the field are using VR and what we can do with that. At this moment, we're not using VR at SVP so much. We use it as a tool for presentations, just to show our clients or other stakeholders with the Oculus Go. We just show them what's the progress of a project. That's already a good addition of presentation, because you see that these people are not working every day with maps and schedules and floor plans, and it's for them hard to see from 2D to imagine the 3D. So with these glasses, they get a really good idea, and it's really an addition. It also we use it for like when we host evenings for residents and people who are living around the projects we're doing. Then we just bring a lot of the cards and card boxes, and they can scan the plan, like this example on the right. They scan the QR code and see on their own phones what the project is. And what we do is then we make an easy 3D tour, so they can go to several spots in the plan, and they stand still there and see all around them. For this project, it's for houses, for starters. And if you show them the 2D plans, they all say, oh, it's really small, we don't want to live here. But when they are in the house with the VR look, then they say, oh, it's quite spacious actually. So it really helps us to sell our plans and to persuade people. But we of course want to go much farther with virtual reality, using it during a design process to improve the design, of course, and also to involve the participants better and earlier in the project. So that's really important to us, that we can show the people that we're really doing something with their input. And that's one of the things we want to do in this project for the international school. What we want to do now, because we're working already 2 years on this project, so a lot of things are already decided. But one of the things we have to do now is find a routing system. So how are we going to show people the way in this big building? So we decided to test different signing concepts and use students of the current school to test these signing concepts. So that's really a good way to use VR for making our design better, and also using people and involve people who are going to use this building. I will tell you a little bit about the project itself, where it is. It is located in Utrecht at the Utrecht Science Park. The international school is for kids from expats, and most of these expats are working on this science park, so it's really a good location to put the school there. The current school is near the Jaarbeurs in Utrecht, so more in the center, and it's really a small, it's too small for them, so they want to expand. One of the features of the location is that it's located on the boundary of the campus, and on the other side, the landscape. So that's what we really want to show in the building. We cut out 2 parts of the building. On the campus side, we make the big entrance, and on the landscape side, we create a big roof terrace, as you can see here. So you can enjoy the views of the landscape, and also we can bring the landscape into the building. Some views to get a better idea, some visuals we've made. So this is the entrance, and the entrance side where everybody will enter the building. And on the other side, you can see that we put a lot of trees and green on the roof terraces, so really to fit it in the landscape. This is a closer look of this roof terraces. And some looks from the inside. This will be the main entrance of the building, and this is the central square. Then back to the VR tests, which we're going to do. So we came up with 3 signing concepts which we're going to test. The first one is concept 0. It's really the basics. So what we're going to do there is just put a number on the big staircase. The big staircase you can see here. So we want to put up a number there so that they can see on which floor they are. I don't think we're going to put the number actually on the glass, because then if you see it from the other side, it will be mirrored. So that's good. We have to do that a little bit different. But that's the idea of concept 0. Just show it on the staircase, and maybe a number next to the door so that you can see which room where you are. In concept 1, we add a little bit. So we emphasize the routing by adding lines to the floor plan and use the lights on the ceiling. And in the second of the third concept, concept 2. It's a bit confusing, but we add some more. We add marks on the floor, and also we put texts on the walls, like for example, library or sports hall, that kind of stuff. For each concept, we're gonna test 2 routes. We call them the blue route and the red route. In the blue one, they start in front of the building. You can see it in the map here. And then they will go into the building and have to find locker room 3 next to the sports hall on the 3rd floor. So they will have to find their own way. They don't know it's on the 3rd floor. They just have to enter the building. And here is an information desk where they get some info. And then they're on their own and have to find it. And in the second route, they're moving from one classroom to another and also have to change floors. So we will see how they are moving in between classes. How we're going to do that for real, it's that we have approximately 100 students. So we all divide them over the 3 concepts. Yeah, because if you have done the route one time, you know the way, so you cannot do the other concept because then our information will be contaminated. So every student does one concept, and in this concept, you will start in front of the building in we call it the VR playground, where they practice a little bit with moving in VR, open doors, using the elevator, that kind of stuff. But we expect that they will be really fast with this because it's all kids, so they are really good with this kind of stuff. Then they walk the 2 different routes, and each route will be timed. So for us, it's really easy to see in which concept they move fastest. What we're also going to do during this walk of them, we're going to track their eyes. So afterwards, we're going to see exactly where they have looked and where there are problems in the routing. And after the test, they take a little questionnaire, so we can ask them some extra information. This is how the schedule looks like. You don't have to read everything, but the most important thing is that, yeah, it's 100 people, so it will take a lot of time for us. What you see here is that we're going to do it in 2 days, and that we have 4 students at the same time. So that means we have 4 headsets there. So it takes half an hour per student. So we have 4 tests per half hour. We need at least 2 classrooms, one for the tests and one for the questionnaires. And hopefully this will fit in 2 days. So yeah, we have to work really hard. After the test, they will take the questionnaire, and there are some questions in there like, do you already have experience in VR, and do you know the building? Because some of the students were already a little bit involved in showing them the plan. So some of them will know a little bit where everything is. So that will, of course, contaminate the data a little bit. And there are some other questions from where do you have problems, and then we can see if the students, what they put in the questionnaire, if it corresponds with our eye tracking, if we can see that back in the tests. So at the end, we'll have different results. We have the time where you can easily see which one is fastest. We have the specific things where we see where they looked, where they had difficulties. We can see from the questionnaire and from the tests. Yeah, and in the end, the idea is that we can choose the best routing concept to put in the building. And the tests are planned for January. And in March, we have to find a way, we have to decide which routing we're going to choose and going to go with. So I think that's well planned. And last but not least, the VR model is a work in progress. Marta and Hans are actually working on it at this moment. So this is just a preview of how it's going to look like. And you see that we have to find a way how we're going to put the marks on the floors, because here they're a lot darker than here. But that's fine tuning, and yeah, hopefully we're going to make it before the beginning of January. So that was this was the presentation. So if you have any questions.
It looks amazing, Leon. We already started having some questions in the chat. And yeah, the first one is actually from me.
Okay.
It's about the device that you plan to use or you use for eye tracking.
The device we're using is the HTC 5, and the eye tracking is something Hans and I think Marta are implementing. So I don't know. Hans,
I can I can jump into the technical part, Leon, if you don't mind.
I don't. Yeah, because I don't know how they're gonna implement it.
Yeah. Indeed, we're using the HTC 5. It's a device with a cable. We're using hardware for it. So we're using a powerful video card for it. You cannot do this with a Quest or a standalone device. So that's an important choice we had to make. You can also do it with the Valve Index. And the eye tracking is done with software. So this in the 5 already knows where your eyes are pointing. So what we try to do is to see, well, let's say that is not completely true, sorry. The device we can test when people start where they are more or less looking at, and we can use the direction of the HTC 5 for the eye tracking. So look what people are, in which direction the device is looking. And then we can estimate which element in the building people are looking at. So it's not a real eye tracking, but it's where the device is looking.
Okay, yeah? It's the direction of the device itself.
Yes, then with that you can estimate where the eyes are pointing at.
Yeah.
Based on where the HTC 5 in the model is, and the beam of where it is pointing at, and where it touches the surface.
Mm-hmm. I think it's a great chance to use this moment for the introduction to Jan Feng. And she was doing a fantastic research about pedestrians' behavior in VR. And maybe Jan, you can just shortly tell what's the status of your project and what have you achieved with the eye tracking so far?
Yeah, sure. Hi, everyone. Yeah, and thanks for the presentation. It's really interesting. And indeed, like Irina said, it's also very close to what I did. So I'm doing my PhD in civil engineering, and my research is about using VR to study pedestrian behavior. And the one big project I did last year was to investigate pedestrian wayfinding behavior in the civil engineering faculty. So it's super close to what you did. Basically, I also asked people to find 3 different destinations in the building, and I want to understand how do they interact with the environment and which routes they choose and how do they find the way. So it's super interesting to see you also doing the similar research. And we also actually use the same device. So I didn't exactly collect the gaze points, but I also used the Wi-Fi and just to calculate according to their head movement, where do they look at basically. Yeah, and I also have some really specific questions regarding this experiment. So I wonder how do the kids or the participants move in the space? Do they use teleportation or they what I did is I integrate a step-by-step movement, because I don't want people mess up with teleportation. They will just jump around. Yes, I wonder what approach you adopt.
Okay, that's a very good question. I will give the word to Marta soon to explain that, because she is our student assistant who is working on this. But we did some tests at SVP with one of the first models, and also tested a couple of different ways of moving around. Also different ways of using the buttons. But I think Marta can explain more, because she did the test and she programmed it. And she decided on how we're going to do it in the real test soon.
Oh, yeah.
Yes. So yes. For the movement, hello, I'm Marta, and I designed the locomotion for this project. And what was really important was that it stays consistent, so that we can actually time the route you're taking. So it's not possible to take shortcuts. So therefore, teleportation wasn't an option for us. We also wanted to keep it as simple as possible. And to try to prevent people getting motion sickness. So what we've done is that we grab the direction of the controller, and then we just let the person glide in that direction. So if you point to the left, then you move to the left. If you going to the right, you will move to the right. And it's just at a consistent speed. So there's no deacceleration or acceleration, which also prevents people from getting sick while they use it.
Yeah. Okay, cool. Yeah, I think we adopt a similar approach. And may I ask another question? Because it's really interesting. I just wonder, like, maybe it's, I don't know if so much relevant to your project right now, but have you thought about like also investigate their route choice under emergency situation? I guess that's also important.
Maybe Leon can answer that.
Yeah, that was in the beginning. It was one of the ideas to check the emergency routings, but yeah, we didn't go with that because yeah, we were a little bit afraid that kids would started to run and trying to do that kind of stuff. But it's, I think, really interesting to test that because yeah, that's also a route that they don't use a lot, because it was also one of the things we were thinking about, because yeah, is routing so important because these kids, they are in the school every day, so they will know the route after 2 or 3 times. So why do we need signage? So for emergencies, that would be really interesting because this route they only take once in a while or never, or once in a lifetime. But in the end, yeah, we didn't go with that also because we don't know exactly where the emergencies are going to be in the building. So that's, yeah, we just didn't do that now.
Yeah, I got that. Okay, thanks. Sounds really interesting. Good luck with the experiment.
Yeah, I think in this case, for this project, we tried to find something which was still designable and where VR could contribute to. And so talking about the project and the proposal from SVP, from Leon and Wilco, we came to the conclusion that doing research on the signet system was the most valuable in this part of the project. And so as far as we can see, it really contributes to developing the idea further, because you do not only have to develop it at the end, but to test it, you already have to design it in a far better way than you would normally do just on paper with saying like, it's like this or that. We have seen the schemes, but from the schemes, implementing it in the 3D model is already raising questions and confrontations, like I think the glass, the idea to put it on the glass, and then when you put it in the VR, the first thing you say like, oh shit, you see it from the backside now. So the first thing you think like, oh, we should do it a different way. So in this sense, the VR also helps the design process, the thinking process. And I think it's great to be able to test it at a school. And the architects and planners, Leon and Wilco, are really thinking with us about how to make the best out of it. So in this case, indeed, you cannot have people run the same route 3 times with different signet systems, because then there's no good comparison between them. Yeah. But you want to compare it, so they have set up a quite good system together with the school. And it's very important to state here as well that the school is involved and is very much very happy that they're involved in this way. They're very engaged, you could say. Yeah. Leon, is there anything you would like to add on the project, from the project itself, from the integration of the VR, etc.?
Sorry, what do you mean? I just want
Is there anything you would like to add on the project itself? Because we have had a couple of technical questions now. Is there anything you would like to elaborate on the project, the role of VR, the process kind of things?
Yeah, for the process, it's we thought in the beginning that it would be quite hard to put it the VR into the already a project that's already on its way. But what we saw is that people, if you tell them that you're going to use VR, that they are really happy and really enthusiastic, because this school they also have virtual reality classes already. Or not, yeah, it's not based around virtual reality, but virtual reality is a part of their class. So what we saw is that when we told them we're going to do this, they said, "Oh, we have our own glasses, so you don't have to bring them, and you can just." Our kids are already experienced with it, so there are a lot of kids who already wanna join this research. So it's raising a lot of enthusiasm, and they also asked us from, yeah, can you give us the model, because then we can do all kinds of stuff in the building already. So what I see is that everybody wants to help, and they're really enthusiastic, and that's one of the things you need to bring a project further. So in that way, the experiment is already a good to bring the design further and let the kids know what we're doing, and they're already asking, when is the building finished? And so you see that's getting a lot of positive reactions.
We also have one question from Meng Li. Would you like to ask it yourself?
Yes, of course. Thank you, Irina.
Yeah.
Yes, thanks a lot for your presentation of this very interesting project. I think my question is about your participants, because kids is a very special group, and usually the headset, the VR headset, are designed for the people that above 13 years old. So what is your empirical experience and your concern that you have learned in these studies? Can you share it with us? Because it's also the concern with a lot of researchers, if they are trying to use VR with in some studies involving the kids as participant or as a co-designer. Thank you.
Thanks for the question, but we didn't do the test yet, so they're going to be in January, so I hope it will be okay. But we tested only on a few kids now, because we tested on at the office for one day, and then there were also some kids. But what we saw is that the kids were way faster than all the adults with moving around in the building, because they already they see it as a game, of course, and it worked actually really well with the kids. And I don't think the headsets were too big or something like that, if you were asking that, but I think that was no problem. But we're also not going with the smallest kids. I think in the test it will be kids from around 12 till 16. So we're not going with the smaller ones.
Okay.
Maybe we can try that as an extra, because the kids are already there. So
okay.
But there are the smaller kids from like 6 years. I'm actually quite curious about that. How they we could try to do that.
Because I think that not only because of the other concern is also because that the kid, their eye are underdeveloping. So I'm a bit curious about what are the ethical permissions that you need to go through if you involving for smaller kids. For example, it's under 12 years old, that what is the special permissions that you need to get for doing this kind of testing?
Yeah, that's actually one of the things why we go for the older kids also, because we have to do with the ethical commission, and we're doing the experiment now anonymous. So the only thing they write down is a number, so that we can correspond their roots with the questionnaire they take and their age. So and the school make sure that the parents are giving their permission, of course. But further on, I think Stefan is also into the ethical commission stuff,
yes,
so maybe you can add something. But
okay.
Oh yeah, I can add something there. Yeah, indeed. Every research you have to apply at HVAC, the ethical committee. And in this case, you have to tick the box that you have kids between 12 and 16, because that's the age we're talking about. Kids below 16, the parents should give consent to that. Well, the consent is covered by the school. The school was very clear in that. First, we made our own consent forms, and we thought about the procedures. And then in contact with the school was very clear to us that we shouldn't do consent forms, and that the school is taking care of the consent. Nevertheless, we are running an ethics application at TU Delft for this. But the research is indeed limited to putting a headset on the students of the school, and letting them move through the building and record that, and no more than that. We record the time, we record the path, and indeed what they're looking at, but it's completely anonymous, so we will not know at all who the students are, what their names are, whatever. We just get a bit of data, and we probably get 100 sets of data, and that's it. So
Okay, yeah, and concern about the, yeah, not only about the, I think the kids, another thing is about the duration of these testing, because yeah, usually for the adults that if they are working in VR for the first time for more than maybe 15 minutes or longer, it can be easily induce the simulation sickness or motion sickness symptom. And what is your consideration about doing this with the kids?
Well, so far we have done lots of experiments with the VR in the VR lab itself and in the field. And we only had a couple of motion sickness issues, but usually people easily stay 20 minutes or longer in the VR. We try to limit our experiments to 15 minutes. We take into consideration the quality of the headset and the quality of the model. So, and also the way of moving around was very important, as we have seen last time when we tested the different ways of moving, different ways of using the control as well. Already that has influence on that. So you can optimize a lot of things there to prevent people from getting motion sickness. We have seen people staying in the VR for an hour. Candidates who are participating, who we asked to be there for maximum 20 minutes, who kept on talking about their neighborhood where they were in, and they were in the VR for 1 hour without issues. So I don't see many issues there. If people get motion sick, well, then we have to take care of that. We also ask people that, and we tell them to tell us, to inform us immediately if they get motion sick or if they get a bit of motion sickness. But we try to prevent it, we try to control it. And finally, I have to say, the kids take this much easier than adults. I think that's what Leon mentioned as well. When we did a test at the office, a couple of kids joined as well. And it was really fun to see how they just, with what speed they turn around and everything, and they jump around, and crazy. I mean, we were not expecting that actually. Yeah. And then the last thing is the school is having these devices as well. They're using it in their classes. So it's not a novel thing for the school. It's not that there's some gimmick we are doing and it's new. So, so I don't see that many concerns, to be honest.
Okay, yeah, thank you. Thank you for your reflections.
It's time to go to the second presentation now. Thanks a lot for questions, and thanks so much, Leon, for your presentation. If you could leave your contacts or any best way to connect with you for the community, feel free to do that in the chat. And now we'll have a presentation from Alisa and Nienke and Renske, psychologist. So yeah, feel free to start.
Thank you, Irina. So welcome to our presentation about biomirror. It's a research into biofeedback and its possible applications in future daily life. And from an early stage on, we are teaming up with the virtual reality field lab to incorporate VR actually in the research process.
So we are Alisa, as you've heard from design studio Alisa plus Nienke, and I'm Renske. I'm a social psychologist and environmental psychologist. And yeah, like Alisa said, we joined the TU Delft and the VRDML lab to work with VR. But first, maybe dive a little bit into our biomirror concept, because it's a bit different than the architecture project you heard before. So Alisa will share a bit on our concept and our future vision on how to use biomirror.
Yes, thanks, Renske. So our design studio is actually specialized in site-specific installations or materials for interior architecture. So we work a lot for office environments, hospitality, and retail spaces. And a few years ago, we started teaming up with the Eindhoven University of Technology with the Future Everyday Research Group, because they are specialized in applying new technologies to future daily life. So BioMirror really originated from this research project, and we had a clear wish to take the biofeedback technology out of its clinical and virtual context and to apply it in a more soft and sensitive way. So together with Bin Yu, who you see on the right of this image, we really teamed up on this subject. So he was promoting on a subject within the research group, and it was great teamwork, and we really used his knowledge and research on how to apply sensors and biofeedback technology. And we combined it with our experience in designing shape-changing surfaces. So together we really looked into what surfaces would fit which biodata. So for example, how would you visualize your heartbeat, or how would you visualize your breathing rhythm? So what is biofeedback technology and how does it actually work? So through a sensor, you actually measure your own biodata. So we use a heartbeat sensor. And when you measure your heartbeat with a PPG sensor, you can actually define the beat-to-beat interval. And your heartbeat actually cycles with your breath, your breathing rhythm. So when you breathe in, your heart rate increases. And when you breathe out, it decreases. And the variation between this is called the heart rate variability, or HRV. And the higher this variation is, the more relaxed you are. So it's really interesting for us as a design studio that with only one sensor, so the heartbeat sensor, you can define both the breathing rhythm and the stress level of a person. So in the end, within this research pilot, we connected the output of the sensor to an Arduino programmed surface, which starts moving based on your own biodata in real time. So here you actually see the paper model moving up and down with the breathing rhythm of a user. And within the project, we want to dive deeper into the spaced breathing rhythm, which Renske can tell a bit more about.
Yeah, so as you can see, this is a breathing rhythm represented by the BioMirror surface. And breathing is maybe one of the only variable of human biodata that we can control. So you can like slow down your breathing, but you cannot tell your heart to just like beat slower. This is why breathing is really an effective tool to reduce stress, because we can control it. And the paced breathing rhythm is maybe one of the rhythms that has been researched as a stress-reducing rhythm. So we know it's already effective, but there are more rhythms, like also from mindfulness and yoga, there are more research rhythms that like reduce the stress. And this rhythm, I actually want to do it with you guys. It's based on breathing in for 4 seconds, then holding your breath for 7 seconds, and then breathing out in 8 seconds. So join me, sit up maybe straight. And let's breathe in. Hold your breath. And breathe out. Okay, this is only one time. Leave me maybe in the comments your experience on how easy you find to do this, or maybe how difficult it is. In my experience, I'm already a bit of a slow breather, but still this spaced breathing rhythm, I need to work on it to really breathe slowly. And that's actually exactly the thing we want to help people with. So our BioMirror surface is going to show a breathing rhythm, and the idea is that people can follow this rhythm, so they don't really have to work hard on it to do it themselves, which normally in the biofeedback systems, people have to put in more effort to slow it down. So
that's also our future goal, to make life-size stress-reducing wall surfaces. So ideally, we want to make these accessible to as many people as possible to learn how to reduce stress by breathing. And in our ideal future, BioMirror will be placed in boardrooms of office environments or hospitals, like patient rooms, as a way for people to reduce stress in a stressful moment. And as a studio, we've had this ambition for a long time, and we've also worked on large projects for architects. But every time we propose applying this in a future project, our clients ask about validation. Does it really work, and what are the results? So that's when we actually went to Renske to team up with a psychologist to really validate what we are working on.
Yes, so when we start talking about people and people using BioMirror, then we actually start to talk about human behavior, which is my field of study. So I do believe that a human behavior perspective is necessary to develop BioMirror further, and especially to make it more applied, because Alyssa and Nienke, they had the vision to apply it in maybe office rooms or hospitals where you interact with people. And that fits my vision as well. From a social and environmental psychology perspective, I like to change behavior. But for me, the topic of well-being and stress reduction, and also using the environment to do it, is something that really fascinated me. And I'm always trying to find these solutions and to work with these solutions. So that's where Alyssa and I and Nienke, we found each other. And the thing I can help Alyssa and Nienke with is actually validating their concept. Because of my science background, I'm able to test and validate and do a bit of the research, and maybe even more also the applied research. So later on we'll go into the offices and yeah, validate the whole concept. So that's what we're doing now. And there is a three-way collaboration starting with. So the TU Eindhoven has more the technical background with the biofeedback systems. Alyssa and Nienke are in the collaboration from the design perspective, and I'll be adding on with the psychological background. But then we found the TU Delft because they had their VRDML call, and it gave us a great opportunity to work with VR as a research tool to test BioMirror. So we took that opportunity and applied, and then we got it. So that's really nice. To use VR as a tool in the design process.
So for us as a studio, this was very new. We've never worked with VR before, not in our process, not in our visualizations. So it was really a novelty. And our process is usually very hands-on. So we design a lot from the material itself. We start testing immediately, prototyping a lot in real life, hold it in our hands, brainstorm, test, and experiment a lot. And we call this a thinking through making approach. So this actually fits co-creation and research projects very well. So we are not only used to use research as the start of a design process or a design part of a research process, but we really want to intertwine these equally. So we usually create and research at the same time. But adding VR opened up a whole new level of possibilities, but of course also a lot of challenges. So here is a glimpse of our VR setting at the moment. Again, it is a novelty for us to create our designs in VR together with the virtual reality field lab. But it has a huge potential in efficiency, but also sustainability, because it would mean that we do not have to create all our designs in real life before we or other people can experience them. So we are currently in the first testing phase of the design aspects of BioMirror. So we are building this environment with different prototypes that people can reflect on. So to the process of the virtual reality design methods lab, how do we actually use it in this project?
Yeah, so our first test round still has to happen and will happen in a few weeks. And we divided the whole process up in two steps, so 2 rounds of experimenting. In the first round, we'll test the design ingredients. So we had like original concept of BioMirror, which is made virtual now. And we want to see all the variables within this concept, how people, what people prefer, and we look into what they think is most relaxing and also where they can see breathing rhythm maybe most clearly. So we have 3 different kind of shapes. You saw one in the video, and there are 2 others. And then we look in the variables of size, so how big will it be in the individual shapes? What is the pop-up height, and also how can we use color application? And we'll also look into different kinds of breathing rhythms where we give in options. So in the first experiment, people, oh yeah, we're also going to dive into the why. That's exactly why I'm in this project, and I forgot to talk about it. So, in this first experiment, we'll use the design aspects as like a way in, but we'll actually want to know the why behind it. So why do people choose for something? And it will, we'll go to the next slide, then it will make more sense. So people will go into different rooms, and you have to think like people will go from one room to the other, and in every room they will have to make a decision about one option or one test about. So first will be shape, which version of biomirror, and there are like 3 different versions. Hopefully that they can choose from. They choose one and they go into the next room. And in the next room they have to choose the option, okay, what is the shape size I prefer? Like, which do I find most relaxing, or in which is the breathing rhythm most clear? If they chose a shape, they will go to the next room, and then we can have like a pop-up height. So this is combined with breathing rhythm. So what kind of pop-up height do people either see the breathing rhythm most clear, or which pop-up height do they find most relaxing? And then they go to the last room where we have 3 different kinds of color applications, which you can also see like which kind do you find most relaxing, or which kind is most clear with breathing rhythm. So all these different aspects we want to figure out. What do people prefer, but maybe more, why do people prefer it? So the whole study is going to be more qualitative. So it will be like interview, like us asking questions, keep on asking, why do you think this? What do you refer to? What kind of association do you make by seeing this shape? Can you elaborate? Can you give metaphors to really understand what people are seeing and why they think things are relaxing? Because if you see this whole flow diagram, there are many possibilities in how biomirror can look in the end. So everyone can have their maybe own favorite version of biomirror, but I do believe by keep on asking questions, we can find similarities in why they choose this option.
Yeah,
so,
with the outcome of this first test, we as a design studio actually go back to the drawing table and try to perfectionize biomirror into one prototype in the end. So then we will again team up with the virtual reality lab to create that perfect prototype, and then we will go on to testing round 2.
Yeah, exactly. So the end goal of phase 1 is to create the perfect prototype, or at least the most perfect prototype. So we know more about design aspects. And in our second round of testing, we actually want to see what the effect is of this prototype on stress reduction. So we don't know the entire setup of the second round yet. It also depends a little bit on what's happening in the first round, and also for us because we are new to VR, so testing with VR is also something we need to experience. But we're going to induce stress in an ethical manner in the second round, and then we put people in front of the biomirror and give them time to follow it. And we're going to use a sensor. I actually have it here. This small device. We're going to clip people to it with a little clip on to measure the heart rate variability and see if biomirror is reducing or increasing the heart rate variability to a more relaxed level. So that's our aim for the second round, but how we exactly are gonna measure it or how we can implement using sensors, we still have to figure that one out, and we still need to learn a bit more about it. But it's gonna be a more quantitative element to our VR testing.
Yeah, so we're almost ready for the final rehearsal next Monday before testing round 1. And we also wanted to share some of the challenges we ran into while working in VR for the first time. So the crux in designing in 3D, because as I mentioned, we have never worked in VR before, and now we have worked with the field lab for a few months. And already the process has been very educational on how this design process works, both virtual and physical. And for example, one of the versions of Biomirror we have never made in real life before. I showed you a paper model before, but this one was always just an idea in our minds. So we really had to find a new way of communication with the field lab, because normally we are making the drawings, and now they are actually creating with our feedback in the process. And even if all of that goes very well and exactly has created what we had in mind, that sometimes we just ended up with a moving surface that didn't feel quite right. So it's very interesting that we now realize that we are used to tweak and slightly adapt while designing, and that part is now missing, which is also interesting to think about this in the future, because it really shifts the ways of working around. But on the other hand, these struggles that we have been experiencing in designing in VR created a really early on learning curve for the designs of Biomirror itself. So we could really experience and adjust far quicker than when we would really have to make it in real life. So it also had benefits. But this is a model that we have created in paper before. So we had a working prototype, which made it very easy to recreate the same version in virtual reality, and therefore really enabled us to zoom into the specific testing ingredients. So what do we want to test, and what can we easily adapt in virtual reality? So this resulted in a way more smooth process, but it also only applied VR as a somehow production phase, so to speak. And without an existing prototype, it would actually feel counterproductive to use this same way of creating a real life model up front before you make it in VR. So these two ways of working or collaborating with the field lab really showed us the difference. So having a prototype makes it very easy to create it in VR, and enabled us to really focus on fine-tuning what we want to test. But on the other hand, starting the design process completely in VR was a very efficient way to create a blueprint of a working prototype that we could recreate in real life. So this first experience in VR for our design process really learned us a lot, but also opened up a lot of new opportunities. And therefore, looking at the future, I think for us it would be really about finding this balance between designing in a virtual world and designing in the real world from an early stage on. So we are also very interested in like what the audience has experienced on this subject, and if other people also move these worlds around or not. So we are curious if you have any experiences to share, but also if you have any questions for us.
We do. Thanks a lot, Alisa. Thanks, Renske. That was really interesting. And well, I wonder if you also plan to use these kind of walls for houses, not for only some educational locations or for offices.
Yeah, that could definitely be one of the outcomes of the process. First focus is actually on business to business, so architects, because that's more our field of expertise, so it's easier to apply the projects in. But we definitely we're interested in a spin-off that it actually lands with every person who wants to have it.
Yeah. So because we have a bigger research project next to this VR project, where we're gonna talk to a lot of people, also about like experiencing stress, where, when, how, which will be maybe in an office context, but nowadays due to Corona, people are working at home a lot more. So we will ask also questions like if in their own living space, what will happen there? So maybe there will be a spin-off but also based on the research we're going to do.
Okay, I see. And we have more questions. Well, I think it would be nice to start with a question from Matthijs. Maybe you'd like to ask it yourself, Matthijs.
Yeah, sure. I was just captured by the movement of the model in the beginning.
Yeah.
And you said that you had the experiment of try to breathe with it, and of course I tried, but I also noticed that my body was kind of resisting to go with the full motion of it. However, I could follow the, let's say, the start and the end of your cycle. So I was wondering, is it a matter of training, or is there a difference between people in, let's say, the breathing curve that they have, which is something that I can imagine that you could quite easily bring into in an algorithm or something. So basically, is there a sort of a fingerprint difference between how people breathe, and can you use that in your design?
So I think there are more answers to your question. First of all, there are people breathe differently. Like the way I breathe and the way you breathe is not the same. So you start in a different way. Then there is the aspect that we know certain kinds of breathing rhythms are more relaxing. So the paced breathing rhythm I practice with you guys is one. But from yoga literature, there's also, they say, double the amount breathing out as breathing in. So for example, if you say 3 seconds in, then 6 seconds out.
Yeah.
And we know, for example, that 6 cycles a minute is also more relaxing. So you can play with it. And then you have the starting point. So what's your own breathing rhythm and what do you want to go to? Yeah. And that's a learning process. So by training, and that's something you do, for example, in mindfulness and yoga, you train to start breathing more slowly, you get more at ease with it. And the interesting research question with us is how can we implement it? So we have like the biofeedback system, where you first see the feedback of your own rhythm, which can be like really fast.
Yeah.
And then by learning curve, we normally say, okay, start to breathe more slowly. And in a graphic manner, they say, for example, the line on the computer needs to drop. Or in our case, the biomirror needs to move more slowly. So you have to breathe slower.
Yeah.
That's one thing you can ask people. But then people have to put in the effort to make it work.
Yeah.
Another way is what we're maybe doing now is called feed forward. So we're giving them an example of this is a slower rhythm and try to follow it. Keep on practicing, try to keep on following it, and as longer as you do it, the better you get at it. But then it's already at a slower rhythm. So in the beginning, it's difficult. You're like, oh no, this is not working.
Yeah.
And I think the algorithm part, which I think Alyssa and I both find interesting, is can we maybe combine the biofeedback system with measuring where you are and reducing that rhythm to a known slow rhythm? So can we create the algorithm that we'll put in the small computer so we can actually help you gradually go there?
Yeah, very nice. Yeah, I had to think of Somnox that you probably will know.
Yeah.
As well, which does it on a different consciousness level, I guess. But yeah, okay. Thank you very much for this presentation. Very nice.
You're welcome.
There is also a great question from Nadia about the ways to clean the wall. Will it only be virtual, the wall? But I guess you explained that now. And how will the wall be cleaned by from the dust?
Well, at the moment, it's a good question. We get it quite a lot with our designs. At the moment, we did not define a final material to produce it in yet. But as a studio, we are quite experienced in finding the right material for a certain design, because actually we use paper a lot in the modeling phase, and then it's always a challenge to find a material that moves or has the similar characteristics but is durable. So we work with loads of different producers and materials, from photo etching steel, so it becomes flexible, to working with textiles with coatings. So we have another wall covering that also has a 3-dimensional effect. It's not moving though. but that one is, for example, made of a woven textile with a coating that you can actually clean with water and also with a vacuum cleaner. So we do focus on that in the end result too.
Okay, yeah, I think that's the last question from Leon.
I was asking which is going to be your test group.
Yeah, so we also, with Corona, we have to like figure a little bit out how we can make it work because we have to, well, fit all the measures. But there will be working people because we.
A question because here we renovated an old school for the needs of school for kids with special needs, hyperactive, autists, and on wheelchairs. So they have a room, feedback room, and it's very interesting. I can write you if they agree to test, to find some, to make something there. It will be interesting.
Yeah, that would be interesting. I think in the next phase when we really start to produce it physically, maybe, because then we are still looking at testing groups. And to get back to the question of Leon, I think Renske now also popped in again.
Yeah.
Yeah, I got kicked out somehow. Sorry. Yeah, so we will start with the work environment because that's more easy. A group of like a test group to find, because everybody, at least most adult people, are working people, and most of them also normally work in an office, or so it's more easily to relate to than, for example, people that go to a hospital. And our first group is more qualitative, so we can have a smaller group. So I think we'll go to 20 or 30 people because we're gonna have like deep dive interviews, which will gain a lot of data that we have to transcribe. And for our second experiment, we have to figure out how many people we need to actually be able to measure the effect. But it depends also on our research design. So we don't know how many people yet we want to have, but it will be in a local network. So if any of you live in Eindhoven, in like 2.5 weeks we'll have our first round, and we are still finding people. So you can join in if you want to, but we do not want people to travel from other cities. So if you live in Eindhoven, then definitely join in, or maybe for the next one if you live in Arnhem, or if you know people in Eindhoven, let us know.
All for participation.
Yeah.
I have some colleagues in Eindhoven, I will tell them.
Cool. Cool.
And the next month you are going to do that in Haarlem as well?
Arnhem.
Okay.
Yeah, so the next one that will probably be, I think, in February, because I live in Arnhem. We'll either do it in Eindhoven or in Arnhem, or maybe in Delft, depending on where we can find people to participate in. Because we're not working with companies just yet, so we cannot ask a company, can you give us your employees? So we have to find them ourselves.
Yeah.
So we have to use our network.
If you do it in Delft, then be sure that you're going to have lots of people there willing to participate.
Good to know, good to know.
Okay, thank you guys. Thanks, Alisa. Thanks, Renske. That was amazing. And I look forward to seeing this wall alive somewhere.
Yeah.
Yeah, it's great that it really helps people, and it really teaches them how to breathe the right way. I think that's a very good mission.
Thank you.
Yeah, and thanks everyone for your questions. Alisa, Renske, if you have any contacts to leave, in case if community members would like to contact you, just feel free to leave them in the chat.
Yeah.
And I think everyone knows about the virtual playground community. In case you'd like to join, just go to Virtual Playground by TU Delft. It's our website, and you'll be able to register as a member and also receive all the invitations for our next meetups. And Leon, Alisa, Rensky, you are also invited. We'll still have 2 more sessions on VR in architecture. It's going to be super interesting. And now I'll give a word to Stefan.
Yes, thank you, Irina. Thank you very much, Leon. Thank you, Alisa and Renske, for presenting today. I really liked the session. And I also see new opportunities. When I looked at both presentations, I was thinking like, maybe we should do this signet system testing also with the heart rate, you know, like seeing if people reflect different ways. So that the bio test integrate into the other test, that would be a great idea, I think. I think the people who joined were very enthusiastic. I see a lot of nice messages on the chat. So thank you very much. Thank you very much for joining. And if you are not able to join, you can always see the recording. And we hope to see you next week.
Yeah, thanks a lot. Yeah, and look forward to seeing you at the next sessions.
Great.
Yeah, thank you, everyone. Bye-bye.
Bye-bye.
Bye-bye.